of Autodesk simulation team, our marketing team, particularly Ajit Yohanan, and our value-added distributor Reddington, and our agency Dune, like to welcome you for this web session. We'll give like a couple of minutes to the other people to join. Still, people are joining in. Let's give them a little couple of minutes to join, and then we will get started with this. I hope my voice is audible to everyone. If there are any challenges, do let us know. If you can confirm that my voice is audible to everyone, would be really nice.
I can hear Sachin. It's audible. Thanks.
Okay, thank you, Ajit, and we'll get started in another minute or so. So we will be recording this web session. If some of the people or your colleagues are not available at this point of time, we will share the recording and we'll take our help from our marketing team to post it onto the open link so everybody can able to access that. Okay, we'll start in a minute or so. Thank you. Okay, we will get started and let the people join in as they get then access to the NetAdd systems and so on. I'll be starting the recording of this session and make it available to everyone out there. So again, first of all, thank you very much for joining in this web session on Design and Optimize with Autodesk Nastran in CAD 2017. And I will be your host for next 60 minutes or so and discussing all about Autodesk Nastran in CAD. And I'd like to thank you, take this opportunity to thank you on behalf of Autodesk simulation team, our marketing team, Ajit Yohanan, and our value-added distributor, Reddington, and our agency, Dune, who has enabled us to reach out to you and get an access to this web session. So before we get started, I'd like to show you the what's there into the agenda and give a quick glance on today's web session. What we are going to discuss on this. Like to take this opportunity to introduce Autodesk simulation portfolio. You've been knowing that Autodesk is world leader in 2D and 3D products like AutoCAD and Inventor. You may be using it, but equally has broader portfolio into the architectural engineering and architectural construction and engineering, and so as in media and entertainment. And I'm going to talk a little bit about onto the benefits of FEA. Though FEA is been into the industry for last more than 40 years, but still when we are discussing on to our management on talking about the FEA needs, we need to convince on why FEA would be needed. So it would be a brief talk, particularly to my colleagues in the engineering and designing field, how they can convince their management and show the benefits of FEA. And then we are going to talk about onto the design and optimization onto the real life case studies. Now here I'm going to run some video streaming, and could be a challenge if your network speed is less. There could be a screen refresh issues, but not a problem. Since we are recording this session, you can always get an access to that one. So what case studies we are going to discuss is something onto the OR build that we often do it. And so as I was doing it before I had access to FEA, and then preventing mechanical failures, particularly issues related to the warranty. Each of the mechanical industries could be in automotive, could be into the machinery, has to do with the warranty and what challenges they face when the product fails into the warranty. And some of that I like to correlate to the real life scenarios. And then optimize the material usage. There have been products which been carried out from centuries together, and I would say sorry to centuries, but in decades together, and nobody has gotten chance to look on those design and dare to make a changes to the product or material, because since it's doing good in the market. But we do have enough opportunity to work upon and optimize in this optimize your design in this challenging world. And then we will share our simulation community and how you can interact with the experts, how you can interact with the users and share your thoughts, ideas on this. So this was a brief agenda, and I welcome that. And I'm Sachin Fulsundar. I will be the host for you for next 55 minutes. I work for Autodesk India Private Limited as a simulation specialist. My colleague Ajit Yohanan is on the other side, and he will be assisting us as and when required on this. Okay, so this is the Autodesk has to offer, and in terms of the simulation portfolio. As I mentioned, that Autodesk is known for its 2D and 3D products, but equally has its broadened portfolio in simulation, and Autodesk simulation family of products and digital prototype solutions enables you to integrate mechanical, structural, fluid, flow, thermal, composites, and injection molding simulation tools into your product development process to help reduce cost and speed time to market. Autodesk provide a wide range of this simulation product portfolio, not only for the analyst, but for the upfront design. And that's what we are going to talk about more onto the upfront design validation. And these solutions are flexible in terms of solving locally and as well as accessing onto the cloud, because cloud is something forthcoming, a next generation of computing. So with this, I like to focus our main agenda of this webinar onto the structural mechanics, and we are going to talk a lot onto the Autodesk Nastran in CAD, Autodesk Nastran, and Autodesk Simulation Mechanical. But as I mentioned, that today's webinar is more focused onto the upfront design, and particularly for the designers and engineers, and I will be focusing more onto the Autodesk Nastran in CAD. Okay, so this gives us a chance to show us the mechanical simulation offering, starting with from the right to left. We have an Autodesk Nastran. I'll talk about the how this Autodesk Nastran is come into the picture. But before on this, I like to show you the mechanical simulation offering. So Autodesk Nastran, as you know, that Nastran already been present into the market for more than 40 years, and the same flavor that Autodesk has also got into their simulation offering. So known for its fast solving with a complex problem solving and faster solving. So these are the main key highlights that Autodesk Nastran has it, or Nastran solution has it. It's the industry recognized FEA solver, and same solver is embedded into the CAD in the form of Nastran in CAD, and I'm going to talk more into detail about the CAD embedded Nastran in CAD solution. But for time being, I will say that it's the CAD embedded NastranSolver. And then we have a simulation mechanical standalone, which comprise of the pre and post processor powered by the NastranSolver, and so it's a, like in standalone solutions where you have altogether a new GUI and powered by the NastranSolver. So in the form of these three products, Autodesk is showing its mechanical simulation offering, but in all and this common, they're all powered by a Nastran solver. Like I mentioned, that how does the Nastran comes into the picture? Okay, Autodesk has put a significant investment into the simulation portfolio. So roughly, if we call today's, it's more than $600 million that Autodesk has invested into the simulations. So right from the solid dynamics, the basic FEA for the linear static analysis to NEI Nastran for solving most accurate complex solution, Autodesk continues to broaden its simulation in coming years, and hopefully if we're given a chance into the forthcoming webinar, we would definitely show more of these technologies that Autodesk is investing, and this is providing more value to our existing customer as well as the new customer who adopts to the Autodesk products. So this was just a glimpse of that, how each of these technologies are powered about. So when I talk about the Nastran in CAD, it's been powered from the NEI software, which Autodesk acquired in year 2014-2015, and so as it comes into our mechanical simulation offering. So now let's talk about something onto the Nastran in CAD. We want to reduce down the curiosity among the attendee, what for they are attending the today's web session. So Nastran in CAD is a general purpose FEA solution embedded into the Autodesk Inventor and solid Dassault Systems SolidWorks. So these are the two CAD solutions where Nastran in CAD get embedded and works for validation of the design. But unlike other solutions that may be embedded into the CAD solutions, it is powered by the industry leading NastranSolver, which is known for its fast solving and the complex solutions, particularly when it comes to the linear dynamics or non-linear dynamics. It's the number one in the industry. So it not only is powered by the trusted Autodesk Nastran solutions, but it comes with all advanced simulation capabilities. Now, many of the CAD embedded solutions just have a very basic functionalities of like an linear static or modal analysis and so on, but this can go up to non-linear or solving a transient type of analysis, or could be a complex solutions like a drop test. Altogether, a CAD engineer or a designer can solve it within the working GA where he is modeling the product. So as I said, it is a CAD embedded. So what's the benefit is that? So we are significantly reducing down the learning curve. So engineer or a designer doesn't have to learn altogether a new solutions when he is validating his design and going with his confidence. And as you know that Autodesk has altogether shift its business from perpetual to the subscription model, so cost of investment has gone significantly low. So don't have to invest onto the perpetual license. You can opt for the subscription license for like a 12 months or 24 or 36 months and so on. So before we go on to the Nastran in CAD and talk about on its capabilities and so on, I want to give a little background, particularly for the managers or the IT team, to show them what's benefit of FEA. As I mentioned that FEA is been into the industry for more than 40 years, but still it's not becoming an integral part of our design process or validation. Still, physical prototypes are the major part of the product life cycle, and I hope you agree with that. And we spend significant time and money and efforts in building up the prototype. So nothing wrong in that, in building prototype, because it helps to validate its functionality and checks. So, but with the digital simulation, you can significantly reduce down onto the physical prototypes. How is by checking onto the different design scenarios and so on, we can go better in time to the market or speed up our product development process and reach to the market faster than our competitions. And now when it comes to the material choosing, there are several options available to choose upon. And there is a trend that is going on is replacing the metal by plastic. Started with automotive, but it is driven all across industry. I hope you agree with me that as well. To check on to the alternative material, we don't want to go back and design again build up the physical prototype, because we are putting the again energy and time in that. So we need to provide more functionalities to stay ahead of the competition, and it's not that the same traditional design will work for now. People want some new innovations, some new changes with more functionalities to come in, and of course the reduced cost compared to the previous. So verifying your digital or design on digital simulations is the best option before physical prototype is built, because this will help you to predict the upfront performance. I say that upfront performance. So this is where you validate and see, cross-check whether what I am designed, what I am going to build the prototype is going to work or not. So now many times a question is been asked to everyone, what's the right time to simulate the do the simulation? But as I see onto the, I like to pay attention onto this one. As we go from the concept to the right to the field, if I put the cost curve across that, it goes high or rises as we pass on each of the milestone. And if you see into the product development process or in the workflow or a cycle, what do you call on that, the concept and the design and engineering are the steps are impacting to the maximum extent. And these are the steps where you can impact maximum to your design before it is released for testing or manufacturing or reaches to the field. And that's where the Autodesk has trying to put the simulation products empowering the designers and engineer where they can do the validation right when they are designing or develop or into the conceptual phase and go with the confidence when they release their drawing or when they submit their product for the further analysis. And I hope you agree with this one, because as you pass through the product development cycles further, it becomes more challenging, more cost to the company to retrieve back and come back and redesign on that. So Autodesk, as I told you that Autodesk simulation or Nastran in CAD works with an Autodesk Inventor and Dassault Systems SolidWorks with users, or I will say a CAD solutions. It's an open network license to share, and a company or organization can have both the flavors of the CAD systems, could be Autodesk Inventor or the SolidWorks systems, and this single license can be shuffled among the users. So it comes as a single network license and works with a multi-CAD environment. So it's open and flexible licensing. Now there has always been question asked about that one is the accuracy of the solutions, and that's where when you are going to reduce down onto the prototype, you are going to believe onto the digital simulation for prototype building. How accurate are you going to simulate? Now here I want to give something thought process that that every of the FEA industry does is validating their solutions. So where they go and validate is with the NFMs. So NFMs is an independent research organization where they help us to check the accuracy of the solutions with the benchmark with the real life problems. So Nastran is always been proving which every release that the solutions remains committed to the accuracy and with the best of the results. So with every release, we test more than 5,000 test problems, and that could be advanced like non-linear, dynamic, or composite, etc. And as I said, that these solutions comes in the scalable form. It can work with the third-party CAD systems here, like SolidWorks, or could be a Autodesk Inventor from Inventor from the Autodesk family. So when somebody asks a question, how accurate is the solutions? Is the something that everybody talks about is a NFMs. So NFMs is the research organization who tests the accuracy of each of the FEA solutions in the market, and we have a report from NFMs and the test problems that we do it. And if anybody wants to have a look at that, do reach out to us. We will be happy to share with you. So I talk about the NastranIn-CAD a lot. Now, what are the capabilities that it can do it? So first, I want to show you the basic analysis capabilities. It's starting with a linear static, buckling, normal modes, and pre-state static and normal modes, linear steady state heat transfer, composite, assembly modeling with contacts, and thermal stress. Now, this we call this as a basic analysis capabilities. But when we talk about the CAD embedded solutions that are currently available in the market, many of them, they just do a linear static, or could be a model analysis, or could to extend a thermal analysis, that too into the linear steady state thermal analysis, and so on. So this is what we are currently getting into the market when it comes to the CAD embedded solutions. But Autodesk goes one step beyond the currently available basic analysis capabilities and empowers the engineer and designers even to do advanced analysis like non-linear static, non-linear transient and heat transfer, non-linear steady state heat transfer, or could be checking a random response, or checking the components response when it is subjected to the particular frequency. This could be useful into the seismic analysis and so on. And then I talked about the transient response. We have an upcoming one case study onto the transient response where we are going to simulate a robot arm swinging, and then it is affecting onto the to the bench on which it is holding it. So that's like a transient response on that. And advanced non-linear and hyper-elastic material capabilities could be simulating of the rubber type of materials can be done if you provided you have the material properties for it. And automated impact analysis drop test, or something like you just show the direction, you come up with the velocity it is falling, or it could be a free falling under gravity. All together can be done with the help of automated impact analysis. So with this, I think I have given you a fair idea on what are the basic capabilities we can do and advanced capabilities and this. So NCAD comes with a single suite. There is no add-on modules available. A NastranIn-CAD, a single suite, it comes with all of these capabilities that shown to you. Now, many people they ask, what's the need of these advanced capabilities? I just want to, get their attention. With this case study, okay, this is particularly a bench. It could be of the sheet metal or could be of the plastics, which when I say bench, the thickness could be not be more than 2.5 mm or maximum up to 3 mm if it is made up of the plastic, or if it is could be made up of the sheet metal, could be maximum up to like 1.2 mm thickness or so on this one. But many people, they do a linear static analysis. They consider this is like a small example why there is need for a non-linear type of things, but we never know how the tendency of the geometry is going to act when it is subject to the load, or so as the tendency of material it is going to behave when it is subjected to the load. So onto the left hand side, I have a result from the linear static which shows the deformation for the same load of 7.6 inches, and the same load same analysis when done with the non-linear static, it shows the deformation of the 0.9. Now this is where comes to proving why there is need for the FEA solutions. Somebody would have just gone with a linear static analysis, and definitely when it is showing a higher deformation, you would have gone and added the material or added the stiffener to improve your design. But there is really no need of that one. The reaction of the geometry or the material is such that the maximum deformation when observed with a non-linear is going to come like an point. So this may land up, if you would have just done a linear static, you would have land up designing a product with more material, and we call it as an O-designed product. So when it comes to the thin wall type of components, could be a pressure vessels, could be a sheet metal components, non-linear static analysis is the best way of performing analysis and take a response from the geometry and material, how it reacts to the material. So these are some of the questions that NCAD can answer when designer or engineers is working on his design. So, and this comes to the questions to the any of the designers and engineers. I hope you agree with. Will my design fail? If it is going to fail, where it is going to fail, and how many cycles does it require to fail, and so on. These are some of the questions. Though these questions are pretty, simple, that's not so easy to do the simulation or predict the number of cycles so easily. Many of the people, they follow the like thumb rules or so on to calculate on those cycles. But when you say thumb rules, you're always taking a chance. It's not an accurate. But with NastranIn-CAD, now with confidence, you can answer these questions: where it is going to fail, how it is going to fail, and how many cycles does it require to fail. So this can be done, calculated, or can be, this type of analysis can be performed in NastranIn-CAD. And can design be optimized? Where do I optimize? With the shape generator combined with NastranIn-CAD, a deadly combination. And and with an CAD embedded in that, you can come up with a much optimized structure. Many of the optimized solutions are available in the market, but they give it the optimized shape in the mesh format. But here, when you work with an inventor and Nastran in CAD, you can quickly sketch upon the optimized structure right into the inventor and come up with the right product. Need not to translate the mesh to the STL, then STL to the some other things and create a sketch around that. But with a Nastran in CAD and inventor, you can optimize your product in much better way. How sooner I can get to the market? As I said, that reduce the number of prototypes, do your design scenario validation into the Nastran in CAD, and skip on the products, skip on the prototypes, go faster with more confidence. Will my design fail? As I talk about, fatigue is something that can help you to predict the life cycle of the product. And Nastran in CAD can enable you to do the prediction of your product life cycle. Could be in the vibrations from the motions, from the non-linear deformations and failures. So now when it comes to the non-linear, many people, they term their non-linear deformation as buckling as well. Okay, something buckling is a little different, and non-linear deformation is something we talk about the I would say called as a large deformation in terms of the non-linear. Well, the people are called as a large deformation, and many people, when it comes to the gas tank or in terms of the pressure vessel, they call as a buckling, but it is a non-linear deformation or large deformation. And comes to the thermal loading also, we can do this thermal loading as well. Can my design be optimized? Very surely, and I have an upcoming example onto the optimization. On many people, the fear of optimization because they don't have the validation tool or tool that can help you gain confidence that whatever I have designed is better than the earlier design, and test different materials and reduce part thicknesses. As I showed you that, shape generator along with the Nastran in CAD can help you to do a best of the optimization in the industry at this point of time and improve your component quality. Now, many questions is been put that quality is something has to do with the manufacturing. It's nothing to do with the design and so on. But if you can properly collect on this, if a designer or an engineer designs a robust product. When you say a robust, from the terms of manufacturability, terms in handling the load, you are designing a better quality product. It's not only the job of the manufacturing team or a process engineers team to develop a quality job, but it is a job of our design team also to give you the best of the components or a robust design. Now, how can I get sooner to the market? By reducing the physical prototype, upfront material testing, increase virtual design iterations rather than developing a physical prototypes to the each and every design, and understand how to simplify the design safely. Not only say simplifying or reducing, but when you are doing so, you should take into consideration safety or factor of safety for which the product has to perform or is been designed for. So with this, I'd like to summarize onto my presentation before I go on to the case study that I talked about a lot onto the Autodesk Nastran, industry recognized Autodesk NastranSolver, powered with the advanced analysis capabilities. None of them has been left, all from the simple linear static to the most complex automated drop test can be performed using the Nastran in CAD solution, and it is an open and flexible licensing solutions, can work with the Autodesk Inventor or could be a SolidWorks. It is a network license, and the best of the part that all designers will like it is the CAD embedded solutions. They don't have to learn a new solutions. It's the same FEA capabilities are going to come into the same GUI where they are designing the product. So with this, with your permission, I'm going to go ahead and talk about the case study, because case study is something that very closely related to the real life scenarios and so on. But as I mentioned that I'm going to do some video streaming over here. It could be a challenging for the people who have less network speed or weak network over there, but not an issue. We are recording this webinar, and you can always view it as per your convenience. The first study, the case study that I like to present here is to determine whether your design is overbuilt and using the NastranIn-CAD. So NastranIn-CAD will utilize here a shell and beam element. Many people, they ask me the questions when it comes to the CAD embedded solution. Are we sacrificing onto the any type of element types? No, we work on the three types of elements. It's a shell, beam, and solid elements can be created into the Nastran in CAD. So with the help of the shell and beam element, we are going to perform a linear static and then dynamic study to determine the weld frame from ASCA, who is one of our customer into the machine design field, and we're able to find it out whether the design is overbuilt. So with this, I'm going to go ahead and try have a look at the case study. I'm going to pause the video on in between to explain you or take you through the details of so on. Okay, so with this, I got a chance to show you how the environment would look like. So we are into the inventor environment, and same GUI now it is going to convert into the FEA GUI. So this is in particularly a robot arm that is being used to weld the automotive parts, and you can see that parts are fit on this fixtures below, and it is going to use for welding as well. And when it is doing a welding, it is going to create a swing actually, and we want to find out how would be the deformation when the swing is happening, and is there any chance to reduce down some of the material from this bench and save some cost to the company. Now if you look at the bench, it looks like a frame type of thing. Now there is two ways to do the analysis of this frame. Go with the traditional approach and just create a shell mesh on this beam, or many people, they just get started with the 3D mesh, which is a very bad way of doing it. I would start with the shell mesh, and Autodesk NastranIn-CAD can help you to collapse this into the shell mesh. And as you see, when I'm collapsing into the shell, each of the shell has its own thickness, so you don't have to go ahead and define the thickness for each of the shell, which is very much automated process. And then comes to the generating a mesh. Quickly, we are going to generate a shell mesh on this one, and then once the mesh is generated, we are going to assign the boundary condition by fixing the legs of this frame and adding a load onto the front bench of around like 2,000 newtons as a robot load, and assign all contacts in one go. You can see that all contacts are assigned in one go as an bonded, or they are called as an welded contact as well. So ease of use is the best way to get started faster and reduce your learning curve. And it solves very quickly. As you know, that Nastran is known for its fast solving. We quickly have the results for the one message onto the top side of the shell, and it shows a value of around like 10.6, and so as onto the other side of the shell is like 12.1. But now same analysis can be done into the beam format. So I just converted or collapsed those shells or the tubular structures into the beam. And now when I converting this beam, I am assigning the sections properties to this beam. Now with the advanced version or the new version, even the beam properties are assigned automatically, taking the section into the consideration. User doesn't have to go and define the cross section as well. So this is a combination of our frame generator and NastranIn-CAD together can define the sections in a very automated format. So purpose is to show that same analysis can be done into the two different form, and using a beam type of elements is the best way of doing this type of analysis, because we want to know whatever the loads that are coming onto the beam, or we want to find it out the actual load. We want to find it out the bending load, which cannot be shown with the help of shell element or a tetrahedral or solid elements. So beam or a line element are the best way to do such type of analysis. So quickly meshing on this one, and then I'm doing it, and solutions is run faster. Then we can go and check on the beam axial force, and then bending moment, and then bending moment in other direction, and then maximum beam stresses or minimum stresses in the beam, and so on. But the best part is to check out the scenario where it is going to swing and create a maximum movement. So before we go on to that, I want to find out the normal modes actually. So this gives me the chance to show whether we can do a model analysis or not. Now I am creating all three different types of scenarios into the same project actually. Just doing a copy paste of that one. So with this I can find it out the different frequencies and which direction those frequencies are there. This is in this on left to right. And this frequency of like two frequencies are very close to each other. You can see that, and now I'm going to run the animation for it. It's into the front. So this is dangerous actually. If it is bending in the front, it's a dangerous. So that's where we have to take a call whether it bends too much where we don't have a chance to reduce any material, or we do have still chance if it is bending is not. That can be found out using the transient analysis. So next step would be to do a transient analysis on that. Try to find it out how the bending occurs when the swing is happening. So I change the analysis type from the linear static to dynamic load, and where I'm going to give some dynamic load, and in terms of the time and the load factor, so 0 times 0 at time of 0.5, I'm going to give a complete load of 2000. So 0.5, I'm going to give a complete load of 2000 newtons, and that's something I call as a shock load. So let it run, and then duration, how many duration I want to do the simulation, and then come up. And so I'll be a little faster over here. And then you can also define your damping. And then quickly generate the mesh and run the analysis and find it out how the displacements versus time required. So displacement versus time shows that the maximum displacement that comes out to be roughly like an 3.6 or 36 microns also, which is very, very less actually with respect to the time. So there are the chances to reduce down some material and increase the deformation actually. So how quickly we can do is that we are still into the CAD environment. We will go and change the physical property or section. So with this, I'm going to reduce from 100 to 80. I'm reducing some material very quickly and doing this analysis very fast. Since it's a beam and elements, it runs very fast. And then we are checking out from, say, so it's still not that high. It's roughly like in 4 micron only. You still have a chance to reduce down. So with this, I would like to show you that how quickly we can do those changes into the our product right into the CAD environment. This is a benefit over the completely dedicated analysis software. So before I go on to that, many times a question is asked: what happens when the product fails into the product fails? So product fail can have a far-reaching effect within your organization, just going beyond your engineering team. Sometimes someone in legal might be a concern with the safety or lawsuits associated with the failure that occurs in the field, and someone in the manufacturing might be impacted by unscheduled rework of machine, and this can disrupt the manufacturing schedule, causing a project delays that could have the dominant effect onto the rest of the organization. So it impacts everyone in the organization. So let's take a more specific example. Let's pick an example on the sales. Sales is often measured in and sometimes it's compensated on the things like revenue and gross profit. A machine failure in the field can have a negative effect onto the customer retention, revenue, and ultimately market share. Costly redesign and rework can drive up the cost of the project, affecting the gross profit. I hope you agree with me that. And delays in the project completion due to effect of machine failures can impact delivery dates and time to the market. So these are all very real business disruption scenarios that can be avoided with upfront simulations, empowering our designers and engineers with the structural FEA solution. So with this, I like to take you through the second case study: avoid the warranty issues by preventing the mechanical failures. So, and validate the assembly using the NastranIn-CAD. So what is the scenario? This is an example that engineering team has given a challenge with investigating the reliability and performance of a brake rotor. And I hope I'm correlating to the one of the products that you might be designing and supplying it to the many of the OEMs. But what is happening with this rotor, particularly this rotor, is that it's leading to the warranty expensive claims due to the warpage and cracks and uneven wear of the brake pads. And challenges extends beyond the simple linear static analysis for the braking force. So here we are going to simulate a couple type of scenario where heat is being impacted or is pushed into this rotor because of the friction, and then we are going to simulate how the deformation in the rotor happens, and can we make the changes in this rotor so that design is made more safer. So this is completely a rotor assembly, but we are going to take a portion of this when we are going to do the simulation, and so as by suppressing the rest of the features or the components in the assembly. And so we are focused on to the rotor, and we are into the GUI. I can see that from the inventor GUI, I directly pushing this part to the Autodesk Nastran with an helping with the plugin. And we are into the FEA browser actually. So, and then we can directly take the material from the Inventor or SolidWorks, and we are going to perform first a linear steady state analysis or linear steady state thermal analysis, and we are going to break down this whole of the components into the elements and nodes so as to perform a FEA analysis and quickly generate a mesh around that. And then we are going to assign a load or a boundary conditions in the form of the convection so that the heat is getting differentiated from all of the part except two of the phases, one on the front that is in touch with the shoe brake or a brake shoe actually, and with ambient temperature of 27 degree centigrade to 293 degree Kelvin, and then we are going to apply a heat flux that is being generated because of the friction of the rotor and the brake pad. So I quickly run the simulation, a steady state thermal analysis, and we can see that how the distribution of the temperature looks like in the completely in this rotor part. And with the exaggerated view, you can do a better viewing by scaling up or running the animation. And then I'm going to change this analysis type from steady state to the linear steady state, and apply some constraints. So this rotor is now attached to the hub. Now you can create the hub, but necessarily it is going to add the features and elements. So as I'm representing the hub in the form of fixing these bolts. Now you can model the bolts also. There is a video on through the how do we create the bolts into the NastranIn-CAD. If you get a chance, go on to the some of the links which I will share it, and you can have a look at that. So I'm going to use a rigid interpolations to transfer the load from hub to this rotor, or when the braking is going to happen. And interpolation looks joints are the best for transferring the load rather than rigid. Rigid is good for the movement. So I'm going to put in actually a moment which is around like 1 to the power 8 of Newton meter, and so as I'm going to apply the same movement into the counter direction as well. And I'm going to create this scenario. Now as you see that I am done with the first with the thermal analysis. In second scenario, I'm going to create something called as an couple type of analysis, where I'm doing a boundary conditions for the structure analysis. But there are something called as sub cases which will enable us to do a multiple this type of scenario. Like I'm doing only a thermal analysis, now I'm doing a structural analysis, and then combination of the thermal and the structural. So with this continuation of the video, I want to show you this type of analysis can be easily performed into the NastranIn-CAD. So just copying this subcase. One was for the structural, and then another is structural plus thermal. And in structure plus thermal, I'm getting a input file from the thermal analysis. Just recently, just now we have run the analysis of the thermal, and then the thermal plus and when we are doing a thermal analysis, I just deleted those load conditions or the moment that applied for the structural analysis. I reduced those boundary conditions. And now I'm going to just run this. So all these three different scenarios will be running parallelly, and no time they are being done. So just have a look at the results with one by one. First, we are going to look at the thermal. Then second is a thermal structural plus thermal, and then just done structural, and see what are the difference and where it is going to land up the issue. So let's look at the one mass stresses or displacement. The maximum displacement that is going to come is around like an 3.1 into the rotor. And this is how it looks like, the maximum deformations. And let's look at the solid one mass stresses. I'm just reduced down, and so you can find out that maximum stresses are built between the vent and just backside of the bolting, or the where this rotor is been bolted to the hub. So it just shows the maximum stresses, and it is beyond the yield point of the material. So definitely it's going to fail. So where are the failure locations? At the bolted joints and in between the vents. So let's have a look at the when we have a combined load of or in the structural. So when comes in the structural, it's maximum onto the into the bolted area actually. So let's go quickly and have the combined load of structural plus thermal. And I'm going to reduce this 5,000 to 2,000 so that we are doing a fair comparison for each of the scenarios. And you can see that, okay, minimum is there, but we are getting a maximum at the alternative vents actually. So each of these alternative vents has their maximum load going beyond the 2,000 2,000 psi of stress. So what would be a next challenge is to how we can make this design more safer is to go back and do some modifications in our rotor design. So we can go and quickly increase the number of vents is the one of the area before we go into this, so that we try to do the distribution of the stresses more uniformly. And since we are into the CAD environment, we can make these changes more quickly and come back to the in CAD. Now we are making a changes. We are back and we are just have to rerun the analysis. We don't have to reassign the material or boundary condition again and have a look at that. Now the stresses has been significantly reduced, though it is high at still at the bolted joints location, but it is significantly reduced into the vents since it has been distributed equally with the increasing the number of vents actually. So with this, we can make a quick changes and make our design much safer. So with this, I will go on to the last case study for today's webinar is on to the optimizing the material usage into the design and improve the performance. And every kg counts when it comes to the saving of the material. I will say every gram counts. But when you talk about the kg, I'm talking about when it is supplied in thousands actually, and that's we save it into the kg. So this is actually a differential assembly that needs to be validated for the given load and check if the material will yield and can we reduce the number of fasteners and save on the cost. So this has been continued for decades with this assembly of the differential and the gear, and they are joined with the bolted, and bolts are something people don't want to touch in because it's like a very critical component and want to always play safe. But with the help of simulation or digital simulation, you can do the validation and check whether there is a chances or probability to reduce down the number of bolts or the size of the bolt. And this is what the next case study is going to talk about on it. So initially I did actually a simulation on this hub and gear and try to find it out what are the stresses that are coming onto the hub and on each of the bolts that are connecting this gear and the hub, and with the probe we can go and check it out the stresses at each and every locations. And bolts, particularly when we talk about the bolt, we want to know more onto the axial forces. We want to know onto the shear forces when it comes to the bolt, both into the first principal direction and second principal directions. So these are very, very critical when it comes to the designing of the bolts. And if you know all these things like axial forces and shear forces, a simple Excel sheet calculations can enable you to decide on the factor of safety. So this is what I'm going to do is I know that axial force here is of like an 67 and shear force in one direction 73, other is 1170, and this gives me a factor of safety of 13, which is well above my design consideration. So I have a chance to look at and try to do some reduction into the number of designs over here. Okay, sorry. So I'm going to go quickly here into the design, and reduce the number of design from 12 to 8 to 12, and I'm going to go back, take this assembly back. And now there is various way to you do the simulation. Somebody would have taken this assembly as it is along with the bolt. No problem, you can do that as well. But when you're taking the bolts, CAD bolts, I will say CAD model bolts, then there is a lot of setups has to be followed, like contacts, and those CAD model bolts may not give you the actual forces or the shear forces. The best way to represent the bolt is with the help of the beam, and we can do it very quickly into the NastranIn-CAD. So I'm just applying a force of like 5,000 Newton onto the teeth, and then I'm going into the connectors and very quickly going to design bolts actually over here. So and this is what a best way to represent the bolt instead of going and designing the CAD, because that will require a lot of contacts, and if you're missing onto the contacts, then it may not give you the proper results, and so as you're going to increase the computation time. But with the 1D type of beam elements, you can do a very quick calculations, and you can also apply a pre-tension to these bolts as well. So I just quickly designed these bolts, and then I'm generating a mesh around it and running the analysis and try to find it out whether the instead of 8 bolts are going to make sense. So I coming up with the actual force significantly. Yes, the actual force has increased from 68 to 73, and so as my shear forces are also going to be increased. Here it is like 322, and here it is also increased to like a 1500 from 1100. So I'll go back to my spreadsheet calculations and try to punch in these values from 67 to 73, and from 73 to 322 and 15, and still you can see my factor of design has reduced from 13 to 9 or almost 10, but still I'm into the well within the factor of safety zone. Still there is a chances I can, next iteration my would be to reduce down the size of the bolt. Now you're saving significantly. When you're saving in few grams per assembly, it becomes a kg when you're supplying it into the large number to any of the OEMs. So like this, we can use the Nastran in CAD along with the CAD systems to validate the design right up front within the CAD systems, and this will empower our designers and engineers to go with confidence when they are designing this type of assemblies or the product. So there are many more this type of examples available on our simhub.autodesk.com. This is then the website. You can go and have a look at it. And there's an example on buckling, there is an example on non-linear stress, and there is an example on heat transfer as well. So before I go and talk about the licensing part of this, I want to share a quick quote from one of our customer. What he wants to say that we went for a Nastran in CAD because it felt into our digital prototype philosophy. Inventor in CAD integration make it easier to make the design changes, and so as I also agree with this, when being into the CAD environment, you can validate the design not only for the basic analysis but at quite an advanced level as well. So, and as I mentioned that Autodesk has moved it from the perpetual licensing to the subscription licensing. Now subscription, you can buy it for like in 24 months, 36 months, or 12 months, 24 and 36. These are the currently available subscription time slots, and all of these licenses are network license. They can be used across the multiple CAD platforms. When it comes to CAD platform, it could be Autodesk Inventor or Dassault Systems SolidWorks. And I'd like to talk few minutes onto the simulation community also. Please subscribe to our newsletters and blog where you can find it. You will find it those all onto our simhub .autodesk.com/tv, where number of videos on Nastran in CAD are available. You can go and look at each of the capabilities of Nastran in CAD if you want to explore or deep dive on that one. But you can always reach out to us by replying onto the mail which our agency has helped us to register on that. You can reach out to our marketing team, and they will help us to get connected with you with this. So with this, I will like to open this forum for the question and answer, and I would be happy to answer your questions. If I cannot able to answer now, I will get back to you. Do let us know your contact details or email. We will reach out to you if I'm not able to answer now. So with this, I will open this forum for the question or answer. So Ajit, are you there? Could you help me to take the questions, or I can go ahead and do that as well?
Yeah, sure, Sachin. I think I just send out a note. Those who want to ask questions can type it here. There was a question about can we ask the questions on AutoCAD? Nice. Yeah, I request any of you has a question, please type it here so that we can answer that.
So any of the things that you felt that I was not covered into the presentation, so I would request that please type in your chat window, and we will make our best to answer the questions. If not, we can able to answer now. We will get back to you on this one. So if you have any questions, do let us know on this.
Meantime, you can take the poll so that we get your feedback. Yes, some of you have asked for the presentation. Yes, we have recorded the presentation and we'll share the link with all of you.
So any questions? Okay, so there are popping up the questions. Ajit, you can take it on.
Yeah, will it be possible to learn this software by own, or there's a need to take help from experts?
I'll take on this question. So, as you say that Nastran in CAD is an embedded solution within the inventor, or embedded solution along with the SolidWorks. The ease of use is what Autodesk has been putting effort to make it such a way that you get along with by yourself. The GUI is being designed in such a way you really don't need any help from the experts to get started on that. There's enough tutorials, enough learning videos are available where you can get started by your own self. I would say give a time of like in 10 to 15 days going through those videos or tutorials, and you should be get going with that one. But to enable you and to handhold you, our partner ecosystem is equipped with that, and they will definitely will help you. Once you buy the license, they will enable you to get started on it.
Okay, the next question is
I
what
hope.
mixed number of mesh?
Okay, so if I put it in this way, what you want to say is that how many different types of mesh we can generate is the mesh we can generate is 1D element, that is a line mesh. The second is the is a shell mesh that I showed it to you. And of course the tetrahedral mesh we can generate it. So all major three types of mesh any of the FEA solution works upon, we can generate into the Nastran in CAD. I hope that answers your question.
Yes, yes, thanks. What is the difference between Inventor and Nastran in CAD?
Okay, so Inventor is an CAD solution from Autodesk, which will enable you to create a 3D model with features. And in CAD, Nastran in CAD is an FEA solution sitting or getting embedded within the Inventor. So whatever the CAD that you are generating, creating could be a product or could be assembly, and how have you designed to make it perform to the expectation can be validated using the Nastran in CAD. I hope I try to answer your questions to the best of my ability on this one. So Inventor is an CAD system, creation of the 3D model, and Nastran in CAD is a plugin or embedded solution within the Inventor for the FE analysis.
Okay, the
Okay.
next question is how can we plot 1/3 octave band plot using any module for motor pump assembly?
How can we plot 1/3 octave band plot using any module for the pump motor answer? Kamlesh, can you little elaborate? I am really finding it hard when you say octave band plot. Is it very specific to the pump industry? If so, if it is very specific, as I said that it's a in CAD is a general purpose FEA solution. I don't know if this requirement is very specific to the pump. You may need to customize some of the plots from the in CAD, but in CAD will allow you to export all the data of pressure, forces at particular point or at particular contacts into the spreadsheet format, and those spreadsheet format can be further be optimized or can be tweaked as per your requirement. Okay, it is more related to the frequency response. Yes, it's another form of measuring the vibration. Yes, it's then if it is related to the frequency response analysis, we are very much able to do it. Yes, we will able to do it on that. Sorry about that. How can we check the mesh quality? Okay, for any of the FE analysis, I understand mesh quality is one of the important criteria, and we do have a mesh statistics where a mesh log which will show you the quality and checks in terms of the aspect ratio, in terms of the element deformation and angles, and you can go and tweak those quality checks. You can refine at particular surface, you can refine at particular region, you can refine at particular vertex. So that's a manual process of doing and improving the mesh quality. But can you do it manually each element wise like you do it into the third-party solutions? Manually correcting the mesh is not possible. You have to assign the control onto the surface. assign the control on the particular part in the assembly, or assign the control onto the particular vertex or edge as possible. So for meshing, what is the value of the minimum required aspect ratio? If we say aspect ratio, the best is the 3. Okay, but it's very challenging to get that. May I check the strength model of the solid? May I check the strength model of SolidWorks via NastranIn-CAD? If Manoj, if I understand your questions correctly, can I use to validate my model in SolidWorks using NastranIn-CAD? If this is a question, yes, you can use the NastranIn-CAD within your SolidWorks. You can use a NastranIn-CAD within your SolidWorks environment to do the validation. What are the customized features for the solver? So customized features, if you can elaborate, I didn't know about what do you mean by customized features for the solvers. How it is different from the Fusion CAM simulation. So yes, we do have a solution from the Autodesk that is called Fusion 360 Ultimate that does has a simulation capabilities, but that are more onto the basic level of simulation capabilities, okay, where you can create only like a 3D type of mesh. Here you can create all these different types of mesh. A couple type of analysis is also possible, and I would say Fusion could be a very entry level type of doing the analysis, though it is helping the concept designers and engineer to do the validation. In CAD is little above that, particularly for the engineers who are working on a bigger assemblies and they want more flexibility in terms of the solving and type of analysis they are doing it. Kamlesh, I can take on your questions one-to-one on to the convergence criterias. Yeah, we do have different types of convergence criterias in terms of the solver accuracy, in terms of the mesh convergence, and so on. If you can drop down your mail or reach out to us, we can have more, face-to-face discussion. I can visit your company and taken the face-to-face discussion, or we can get on to the call as well. I hope that will help us to resolve your queries much faster. Any more questions from the, particularly I am looking from the designer or engineer community, and I hope if they adopt to these inbuilt capabilities, I'm very sure they can design the product with more confidence. Any more questions? Okay, if there are no more questions, I like to go. How would it be better to change it? How it would be better to change it? What does it mean by better to change it? Fusion analysis versus Nastran analysis, fusion analysis versus, okay. Oh, well, fusion is something, as I said, that it's at the entry level or at the very beginner level for the concept designers who want to try out the design validation upfront. But Nastran in CAD is a little ahead or on the top of the the fusion analysis. As I told you that, they differ in terms of the mesh. It can have better flexibility in terms of mesh, refining it, and so on, and in terms of the analysis capabilities as well. So if you can go onto our website, you can find the clear differentiation in terms of the capability wise versus the Fusion Ultimate and Nastran in CAD. So any more questions? So if there are no more questions, I like to stop the recording, and we will make this recording available to each of one who've been part of this webinar, and like to thank you all for attending this webinar. I hope it was useful and get some more information about the Autodesk simulation portfolio, and how Nastran in CAD can enable you to design the product with more confidence before you go and releasing the drawing. So with this, on behalf of Autodesk simulation team, our marketing team, our value-added distributor Reddington, and Dune agency, I like to thank you all for attending this webinar. Thank you very much.